Okay, this is the brief on new trends in AI software development. So, the software world, it's shifting fast. We're moving from humans coding to AI orchestration. You've got tools from simple helpers to autonomous systems building whole apps and automating business logic. Okay, first, two new coding styles. Vibe coding, like Bolt, uses quick chats for fast prototypes, MVPs. But careful, it can be insecure. Then there's spec-driven development, SDD, much more rigorous. You write a formal spec, the what and why. Then the AI plans and builds cleaner, scalable code. Second, deeper automation via agents and workflows. Autonomous coding, think Google's Jules, means AI does full code changes, uses the terminal, tests itself. Then, agentic workflows, like in n8n or Zapier. Here, AI agents act like digital humans coordinating business tasks, say, customer service or lead gen across apps. Finally, basic AI assistants like Copilot, still key for productivity, but huge risk. LLMs are often insecure by default. Trained on public code, they can generate big vulnerabilities, SQL injection, even hallucinated dependencies, where the AI invents fake packages. Human oversight is absolutely mandatory. Bottom line, our roles are evolving. Less line-by-line coding, more being architects and careful security validators for these AIs.
Welcome back to the Deep Dive. So last time we really laid out the groundwork, didn't we? We covered those 7 big shifts shaking up software development.
We did.
Yeah.
Autonomous coding, AI agents, agentic workflows, SDD, vibe coding, AI IDEs, AI-assisted coding. Yeah, the whole landscape. We defined them.
Exactly, the definitions. But today we're moving past just knowing what they are. Our mission is much more critical, I'd say.
Agreed. We're taking that list and putting it through its paces.
Yeah.
A full spectrum SWOT analysis.
A SWOT. Strengths, weaknesses, opportunities, threats. Because, everyone wants the quick actionable knowledge, the what tool should I use now info.
But you can't just jump on the bandwagon, not with this stuff.
Yeah.
There's so much hype flying around.
Right.
You absolutely need critical thinking. We have to look beyond the flashy demos. What's actually practical? What are the real risks? Is this sustainable or just, the flavor of the month?
So that's the plan. We're breaking it down into those 4 pillars. Strengths, what these systems are inherently good at, their internal pluses.
Right. That weaknesses, the internal limits, the practical headaches, what makes them maybe stumble today.
Then we look outward. Opportunities, the market potential, the new business models popping up.
And finally, the big one. Threats, the external risks, security, governance, trust, all the stuff that can really bite you if you're not careful.
We've pulled together insights from, all over. Cutting-edge platforms, cloud IDEs, new protocols, developer feedback, the works.
The goal is for you, listening, to walk away with a much clearer picture, like a blueprint for where to focus your energy, and maybe more importantly, where you need to proceed with, let's say, extreme caution.
Okay, let's dive in. Where do we start?
Let's start with the good stuff, the immediate wins. Section 1, strengths. What are the core powers these systems bring?
Strengths. And S1, the first one, it just jumps out, doesn't it? It's the sheer speed, the productivity boost.
Massive acceleration, yeah. And that move towards unsupervised runtime. We see this especially with autonomous coding and vibe coding.
It feels like it's fundamentally changing the distance between just having an idea and actually having working software.
It really is. That capability, that's the core of this whole shift. Think about traditional development.
Yeah.
It's step-by-step, detailed instructions.
Right. Painstaking sometimes.
Autonomous coding just leaps over a lot of that. It takes a high-level intent and idea and turns it into this iterative, self-correcting coding process. It's the closest we've gotten to, true automation in development.
And the examples are getting pretty impressive, like Replit Agent 3?
Yeah, the numbers there are fascinating. Our sources are saying it can now run autonomously for, over 200 minutes?
Over 200 minutes. That's more than 3 hours running by itself.
And it's not just churning out code blindly. That's the key point. It's testing that code, finding errors, looking back at its plan, fixing things, dealing with dependencies, retesting.
And actually getting to a functional result. All while you could be, grabbing coffee.
Exactly. You could literally dictate an idea for, say, a basic scheduling app into the Replit mobile app, go do something else for 3 hours, and come back to find a working MVP.
That completely collapses the idea to prototype timeline, from days or weeks down to hours.
And that speed links directly into vibe coding too, doesn't it? Which is all about maximizing that speed, but also accessibility, making it usable for, well, non-experts.
Right. The promise there is huge. Tools like Windsurf are claiming you can build a whole app with just one prompt, essentially by conversing with the AI.
Yeah, the goal is speed and creative exploration first. It lets someone who knows the domain, like a marketing manager or maybe a scientist, sort of talk the software into existence without needing to know all the syntax details.
Okay, so that's speed and autonomy. What about S2? Orchestration and scalability. This feels like the territory of AI agents and those agentic workflows.
Exactly. This is where the AI stops just being smart in a box
Right.
and actually gets, hands and feet to interact with the world, or at least with other systems.
Hands and feet. I like that. So it's different from old school automation.
Oh, completely. Think about traditional automation like rigid scripts or maybe scheduled tasks. They only do exactly what they're programmed for. No flexibility.
Right. If anything changes, they break.
But AI agents are dynamic.
Yeah.
They work on this kind of three-step loop. First, they understand the request, the high-level goal. Then they think they figure out the best plan, maybe multiple steps to achieve it. And finally, they act using the tools and APIs they have access to.
Ah, the tools. So the APIs are the hands and feet, like connecting to QuickBooks or Salesforce.
Precisely. Those tools let them bridge different systems in a way that used to require really complex, brittle custom code.
And the complexity these workflows can handle now. It seems like it's scaling up fast. Platforms like NAAN or Make.com talk about limitless integrations.
Yeah, NEN mentions integrating with over 500 apps and AI services alone. That's huge. Yeah. But what does a truly scalable workflow look like? It's not just one action.
So give us an example, like maybe a sales process.
Perfect example. Traditionally, managing a full sales cycle involves multiple systems, manual steps, passing info back and forth.
Yeah, lots of room for error.
Right. But an AI agent could orchestrate the whole thing. It pulls the latest client info from the CRM, maybe Salesforce. Then it hits the e-commerce platform's API to check their recent purchase history. Based on that, it decides the right discount, generates a personalized invoice using, say, the QuickBooks API, sends it out, and logs the whole transaction, maybe attaching the invoice PDF to a Trello card.
Wow. All autonomously, connecting all those different systems.
All autonomously,
Yeah.
making decisions along the way. That ability to link disparate systems with flexible logic, that's the massive leap in scalability they offer.
Okay, let's shift gears to S3, deep contextual code understanding. This is the realm of AI IDEs and assisted coding, right? The tools living right inside your editor.
Yes, and this is a fundamental shift from older code assistants. For years, it felt like they only knew about the specific file you were working on at that moment.
Totally. Like autocomplete on steroids, but not much more.
Exactly. But the new tools, they're moving beyond just predicting the next token. They're actually understanding the structure of your entire project.
How do they do that?
Tools like CodeGPT, which you find in VS Code or JetBrains IDEs, they build an internal knowledge graph of the whole code base.
A knowledge graph.
Yeah, it maps everything. Function definitions, how variables are used, all of the dependencies between files, the complete call trees, the whole architecture.
Okay, that is a game changer because it means if I ask it to create a new function in one file,
it knows how that function needs to interact with classes or functions in totally different files. It understands the necessary imports, the dependencies, everything.
So the suggestions are actually relevant to my project, not just generic code snippets. And I don't have to leave my editor to figure it all out.
Precisely. And this depth isn't just for general code. Look at Google's Gemini Code Assist for database work.
Ah, right. SQL and databases.
It provides schema-aware code generation. The AI actually understands your database structure.
Yeah.
Tables, columns, relationships, constraints.
So it can help write better SQL queries. Or even optimize them.
Yes, and it can generate natural language query optimizations that actually respect your specific schema, preventing common errors. It goes way beyond basic query help.
Okay, one more strength. S4, rigor and alignment with intent. This sounds like the territory of spec-driven development, SDD, sort of the structured alternative to vibe coding.
Exactly. SDD puts the specification in the document that details the what and the why of the software front and center. It becomes the main artifact, the source of truth.
And the code itself.
The code becomes almost secondary. It's just a technical derivation based on that spec.
Okay. But what's the big win there? Doesn't writing a detailed spec first slow things down?
It might seem like it, but it builds in guardrails from the start. It enforces quality because the code must align with the agreed-upon requirements in the spec. You ensure the final product actually matches the original business need.
So how does AI fit in? Does it help write the spec?
It helps at every step. AI can help generate the initial detailed spec. It can create the design blueprint from the spec, and then it implements the code based only on that spec. It combines AI speed with traditional planning rigor.
I see. So you get speed and structure.
Precisely.
Mm.
Tools like Kiro or GitHub's Spec Kit are built around this idea.
Yeah.
The result is software that's usually more maintainable and less likely to drift away from the original intent over time.
Mm.
Okay, so we've seen the power, the potential. It's inspiring stuff.
Yeah. Makes you want to jump right in.
But now we need that dose of cold realism. We have to talk about the weaknesses, the internal challenges, the things that make these systems, well, sometimes unreliable or inefficient or just plain expensive to use day to day.
Right, the practical limits. And the first one, W1, seems pretty obvious. Resource overhead and cost. Running these autonomous agents especially isn't free, is it?
Not even close. That's a critical point people often miss in the excitement.
Yeah.
Running fully autonomous agents takes serious computational power.
Because they're using those big language models constantly.
Exactly. They need powerful GPUs, usually in the cloud, and they chew through tokens like crazy. Remember that iterative cycle. Generate code, run it, oh, it failed, think about the error, ask the LLM for a fix, generate new code, try again.
Each step costs tokens.
Each step burns tokens. So if the agent gets stuck on a tricky problem and iterates dozens of times,
The meter is running fast, much faster than maybe a human developer who spots the issue quicker.
precisely. For a big company, maybe the time saved justifies the API costs. But for smaller teams or personal projects, heavy autonomous use can absolutely blow through budgets surprisingly quickly.
And we've seen this before, right? Weren't earlier agents criticized for being token hogs?
Yeah, tools like RuCode or Clang face that criticism. It shows efficiency isn't guaranteed, and you really need to be mindful of that cost structure. Long, unguided autonomous runs can get very expensive.
Okay, which leads us nicely into W2, error propagation and debugging issues. This seems especially problematic with things like vibe coding, where the AI might generate a lot of code quickly.
It's a really insidious problem. The AI spits out this big chunk of code dump, basically. It looks plausible, maybe it even mostly works, but there's a subtle bug hidden in there,
And the developer might miss it initially.
understandably. And then, here's the spiral. The developer finds the bug and tries to fix it by just asking the AI again, hey, AI, fix this error.
Which seems logical, but
But the AI can get stuck in a loop. It might be constrained by its own limited view, the context window. It might be confused by its own previous error, or it might just hallucinate a fix that doesn't actually work or makes things worse.
so it struggles with complex, stateful debugging.
It really does. Maintaining that coherent understanding of the whole application state during a tricky debug session is hard for the current models.
There was that great real-world example you mentioned, the vibe coding session with the kaboom.js game.
Oh yeah, that was perfect. Developers building a simple game gets this persistent cannot jump error. They see the error message back to the AI, ask it to fix it. The AI tried multiple things. Changed syntax, restructured code. Nothing worked. It just kept failing.
So what did the developer do?
They had to give up on the AI fixing it directly. They fell back to totally traditional methods. Opened Google, searched the official kaboom.js documentation, found the actual issue, some constraint the AI was unaware of, figured out the solution themselves, and then fed that specific verified context back to the AI to implement the fix.
Wow. So the AI couldn't solve it, but it could implement the solution once a human found it.
Exactly. It proves you still absolutely need that deep traditional debugging skill, the ability to step outside the AI's world and find the ground truth. You can't just rely on the AI to fix its own complex mistakes.
Okay, weakness number 3, W3. Integration friction with legacy systems. This is where the shiny new AI agent meets the messy reality of most companies' existing infrastructure.
Yeah, this is a huge one. The sources put it bluntly. Legacy systems don't just integrate smoothly. They negotiate, resist, and occasionally break in unpredictable ways.
Sounds familiar.
The problem is, AI agents need reliable, consistent data to do their planning. That think step relies on understanding the current state accurately.
But in a typical enterprise.
You've got data scattered everywhere. Separate inventory systems, ancient ticketing platforms, maybe an old IPM system for network addresses. Often with conflicting information, inconsistent formats, maybe documentation that's years out of date, or APIs that barely work.
So if the agent needs to say, check network availability before deploying something, but the IPM data is unreliable.
Its whole plan falls apart. It can't reliably figure out what changes are safe or validate configurations because the input data is garbage. It lacks that trustworthy, queryable model of the real world.
Which means...
Which means someone usually has to do a ton of manual work, first writing custom adapters, cleaning data, building middleware, just to prepare the environment before the agent can even start its supposed autonomous task.
Kind of defeats the purpose of friction-free automation, doesn't it? It certainly adds a layer of hidden work. Okay, final weakness, W4. The ongoing need for deep human oversight. This applies across the board, doesn't it?
Absolutely. This might be the most crucial realization for everyone listening. These LLMs, these agents, they don't replace your expertise, they amplify it.
Explain that. Amplify, not replace.
If you already know your stuff, if you're a skilled front-end dev, or you understand database design or, networking inside out, then the AI is an incredible force multiplier. It takes your knowledge and boosts your output massively.
But if you don't have that underlying expertise,
then you're kind of flying blind. You can't effectively judge the quality of the AI's output. You don't know when it's subtly wrong. You can't guide it effectively or refine its suggestions in a meaningful way.
So the developer's role isn't vanishing, it's just changing focus.
Exactly. It's being redirected. We looked at videos of people using vibe coding, autonomous tools.
Yeah.
Almost universally, the creators were clearly experienced developers.
So what were they doing differently?
Their job shifted. Less typing line-by-line code, more evaluating the AI's output quality, managing the overall context. Is the AI still on track? And crucially, having the judgment to know when to hit pause on the automation, step in and fix things manually because the AI is going off the rails or produce something substandard.
Even with the structured approach, like SDD.
Even there, the human still has to review the AI-generated plan, look at the task list it creates, and iterate on that specification based on what they learn. The guidance is explicit. Do not treat its first attempt as final. Human judgment remains absolutely essential.
Okay, we've navigated the strengths and definitely felt the weaknesses. Now let's look outwards. Let's talk opportunities. The external potential, the new markets, the new ways of doing business these tools are creating.
Yeah, this is where it gets really exciting again. Because these technical shifts we've discussed, they're spawning tangible business opportunities incredibly quickly. Things that just weren't feasible a few years back.
So, O1, first opportunity. The rise of the AI automation agency, the AAA model. What is that exactly?
It's basically small teams or individuals selling custom internal tools and automation solutions, often built using these newer, faster methods, especially leveraging no-code or low-code agent platforms.
Targeting who? Big enterprises?
Mostly small to medium-sized businesses, actually. The ones that need automation desperately, but don't have huge IT departments or budgets for massive custom builds.
And there's demand for this.
The market data is pretty wild. One estimate suggested that for every one person or agency offering these AI dev services, there's something like 1,100 businesses in the U.S. alone that need that kind of help.
Wow, 1,100 to 1. That's a massive untapped market.
Huge. And the barrier to entry for starting in AAA has plummeted, thanks to tools like Replit Agent 3 or workflow platforms like NAKN and Make.com.
Right, you don't necessarily need to be a super senior full-stack guru anymore to deliver real value quickly.
That's the key. These agencies can focus on high-impact, specific needs, like building a custom AI image generator trained on a company's specific brand assets for their marketing team.
Or maybe a chatbot trained on internal onboarding docs for new hires.
Exactly. Things like that. Built fast, often using conversational prompts or agent workflows, solving real bottlenecks for businesses that couldn't afford traditional custom software development.
Okay, cool. Opportunity 2, O2, enabling multi-agent and agent-to-agent ecosystems. So moving beyond just one AI doing everything.
Yeah, the idea is that the real power isn't going to come from one giant monolithic AI agent trying to be a jack of all trades. It's going to come from specialized agents collaborating.
Like a team of AIs.
Sort of. Think a finance agent, a marketing agent, a logistics agent, each expert in its domain, but needing to work together on complex tasks.
But that brings back the integration problem, doesn't it? If my finance agent is built on platform X and the marketing agent is on platform Y, how do they talk effectively? Is it just back to brittle APIs?
That's the challenge these new protocols are trying to solve, like the OpenAgent 2 agent or A2A protocol. Google's using it in their agent-based platform.
And what does A2A do?
It's designed specifically to let agents built on different underlying models or frameworks communicate smoothly. They can discover each other's capabilities dynamically, pass information back and forth, and keep track of the overall goal across the team. It breaks down those platform silos.
So you could build really complex cooperative systems.
Absolutely. Imagine like a self-optimizing content creation pipeline.
Yeah.
You could have one agent using Perplexity for deep research, handing off its findings to a Gemini-based agent to draft the actual article.
Maybe another agent updates a status tracker in a Google Sheet.
And a final agent takes the approved content and posts it to WordPress. A whole assembly line of specialized AIs coordinating automatically, far beyond what simple automation could do.
Okay, O3 brings us back to spec-driven development. You mentioned rigor before, but the opportunity here is focused on migration acceleration. How does SDD help move off old systems?
It comes back to that core idea. The spec is the enduring artifact, the definition of intent. The code is just the current implementation of that intent.
So the spec holds the real value.
Exactly. And that gives you a massive future-proofing advantage.
Yeah.
Think about moving off an old mainframe system, usually a nightmare project, right? Years of complex lift and shift.
Oh, yeah. Painful.
But if you use an SDD approach and you have that solid, tested, executable spec, well, 5 years later, when you want to move to a completely different tech stack, new framework, new database, new cloud platform,
You don't just migrate the old code.
you could potentially just feed that original spec into a newer, smarter LLM and have it generate a native implementation for the new environment. It radically accelerates that kind of transformation because the intent is preserved and portable, independent of the specific code.
That makes the spec incredibly valuable, like the core IP.
Precisely. It protects the business logic regardless of the underlying tech fads.
All right, final opportunity, O4, accessibility and workflow integration. This feels like AI becoming less of a destination tool and more just part of the furniture.
Yeah, it's about embedding AI capabilities directly into the tools people already use every day, democratizing it, basically.
Like Microsoft's Copilot Studio.
Perfect example. It lets organizations build and publish their own specialized AI agents, maybe using generative AI for complex tasks, and make them available right inside Teams or SharePoint or the main Copilot chat.
So employees don't have to go somewhere else to use the company's specific AI.
Nope, it meets them where they work. It becomes part of the natural workflow.
And Google's doing similar things.
Absolutely. Google AI Studio is positioned as the central hub for building custom apps on their Gemini models. They give you API keys, usage tracking. They're setting it up so integrating AI becomes a standard part of development.
They even have that real-time screen sharing for problem solving with the AI, right?
Yeah, allowing live collaboration between a developer and the AI assistant. It's all about making AI an integrated, accessible utility, not a separate, scary thing.
Oh, okay.
We've covered the good, the challenging, and the exciting potential. But now we hit the really critical part, the threats.
Right. This is the stuff that requires serious attention, robust strategies. Ignoring this is where things go badly wrong.
This is definitely the pay attention now moment. Because adopting these tools casually, without understanding the risks, that's dangerous.
Let's start with T1. You called it the vibe coding security paradox. The idea that AI-generated code is often insecure by default. Why is that?
It boils down to two things: the data the AI learned from and what its main goal is.
Okay, break that down. The training data.
LLMs are trained on absolutely massive amounts of public code, think GitHub, Stack Overflow, etc. And let's be honest, a lot of public code contains security flaws, bad practices, outdated techniques.
So it learns the bad habits along with the good.
Exactly. And then there's its objective. The AI's primary goal is usually functional correctness. Did the code run? Did it solve the user's immediate problem? It prioritizes that over security, unless you explicitly tell it otherwise.
So it might generate code that works, but is riddled with vulnerabilities because those patterns were common in its training data.
Precisely. It defaults to reproducing those vulnerable patterns it saw so often.
Can you give a concrete example? Like, how might this actually happen?
Sure. Classic one is SQL injection. Imagine a developer asks the AI, write me a Python Flask function. Take a product ID from the URL. Use it to get details from the database.
Seems like a standard request.
Totally standard. But the AI, remembering countless examples from its training data, is highly likely to generate code using simple unsafe string concatenation to build the SQL query. Like, select from products where an alias plus productive n.
Ah, the classic CWE89 vulnerability, textbook SQL injection.
Textbook. The code works functionally. It gets the product details, so the AI thinks, job done. But it's a security nightmare waiting to happen. Unless you specifically prompt for parameterized queries or other secure methods, it defaults to the insecure pattern it learned.
Okay, that's scary. Now T2 sounds even weirder. Novel supply chain threats via hallucinated dependencies, also called slop swatting. This is unique to AI, right?
It is, and it's critically important to understand. It starts when the LLM, maybe while generating code or suggesting libraries to install, just makes one up. It hallucinates a package name.
It suggests installing something that doesn't actually exist.
Exactly. It might sound plausible, like color picker utils or async helper v2, but it's not a real package on PyPI or NPM or wherever.
Okay. So where does the threat actor come in?
They're watching. Attackers actively monitor AI outputs, maybe forum discussions, looking for these hallucinated package names that developers might be trying to use.
And when they find one?
They quickly register that exact name on the public package repository, PyPI, NPM, etc., and upload their own malicious code under that name.
Oh, I see where this is going.
Yeah. Then a developer, trusting the AI's suggestion, oh, I need async helper v2, let me install that, runs pip install async helper v2 or npm install async helper v2.
And pulls down the attacker's malware instead.
Bingo. They execute the malware, potentially compromising their machine, their company's network, their deployment pipelines, all because they trusted the AI's hallucinated suggestion. It turns the AI's helpfulness into a vulnerability.
That's insidious. Okay, T3, governance and misconfiguration. This seems especially relevant for those AI agents and platforms that promise to build entire applications autonomously. Giving an AI that much control
Requires serious guardrails, robust governance, audit trails, everything. You're potentially giving the AI the keys to the kingdom, right? Database write access, maybe ability to modify user accounts, deploy code.
That level of power needs oversight.
Absolutely. And a prime example of where this goes wrong involves those platforms like Lovable or OnSpace.ai that accelerate full-stack development. They generate huge amounts of code quickly.
But their security depends on.
It depends entirely on the user correctly configuring the back-end security measures. Things like super-base row-level security, RLS.
Okay, remind us quickly, what's RLS and why is it tricky?
RLS lets you define rules in the database itself about who can see or modify which rows of data. Like user A can only see their documents, user B only sees theirs. It's powerful.
But complex to set up.
Very complex. It often involves writing detailed SQL policies. Novice developers, or even experienced ones moving fast, can easily mess these up. They might accidentally write a rule that gives everyone access instead of just the intended user.
And that happened with one of these platforms.
There was a reported incident involving Lovable, yeah. Developers, likely overwhelmed by the speed of the AI generation, misconfigured the RLS rules, leading to significant data exposure vulnerabilities. The AI built the app fast, but the human oversight failed on the critical security configuration.
The AI accelerated the creation of the vulnerability in a way.
In a way, yes.
Yeah.
Because the human couldn't keep up with securing what was being built so quickly.
Okay, final threat, T4. Accountability and trust in these hybrid workflows. If an AI is writing, say, 95% of the code, who is actually responsible when something breaks or a security flaw gets through?
This hits right at the heart of professional integrity and team dynamics.
Right.
Think about traditional code reviews.
Yeah.
There's a human connection, right? Peer pressure, professional reputation, your colleagues are looking at your work, and you want it to be good.
Right. There's accountability baked in.
Exactly. But if an AI writes the code, and maybe another AI reviews it, that reciprocal human accountability is gone. Who feels responsible? Does the AI care about its reputation?
Obviously not. So how do we solve this? We can't just not use AI review, can we?
The solution seems to be structuring it carefully, with humans still in the critical path. The human-in-the-loop model.
Meaning
Organizations must maintain clear lines of responsibility. The human developer ultimately signs off. They remain accountable for the quality, the security, the correctness of the AI-generated code, even if they didn't type every line.
So the human is the final gatekeeper.
Has to be. You need structured approval processes, rigorous testing cycles where humans are involved. Anthropic's Claude Code team is a great example. They apparently use AI for something like 95% of their coding.
95%.
Yeah, but crucially, they also use AI review agents working alongside human engineers who provide rigorous oversight and final validation. The human retains ultimate responsibility. That's how you maintain quality and integrity. #TAG outro. So let's try and synthesize all of that. We've been through the strengths, the weaknesses, the opportunities, the threats. What's the big picture takeaway from this SWOT analysis?
Well, it feels like there's this fundamental tension, right? Between the raw speed and autonomy everyone wants and the absolute need for structure, rigor, and just knowing you can trust the code.
Exactly. And that leads to a couple of key conclusions for anyone listening and trying to figure out how to navigate this.
Okay, conclusion 1 seems to be about choosing the right tool for the job, specifically looking at autonomous coding versus spec-driven development.
Right. Autonomous coding, like that Riplet agent running for hours, it offers maximum speed, maximum hands-off potential. But, as we saw, it comes with heavy oversight requirements, potentially high costs, and that inherent risk of baking in vulnerabilities if you're not careful. It seems best suited for experiments, internal prototypes, maybe things that aren't on the critical path.
Whereas spec-driven development.
SDD provides the rigor you need for serious, scalable projects. But locking down the spec first, the what and the why, before the AI generates the how, you get alignment, you get maintainability, and you get that future-proofing benefit for migrations down the line.
Yeah.
That feels like the approach for mission-critical systems.
Okay, conclusion 2 feels more about the day-to-day developer experience. Comparing vibe coding with the integrated AI coding IDEs.
Yeah, vibe coding is fantastic for lowering the barrier to entry. Right? Great for brainstorming, rapid prototyping, letting non-coders get ideas out. Super accessible.
But again, the but.
But, as that debugging example showed, it relies heavily on the human director having real technical chops. You need the expertise to manage the AI's context, steer it when it goes wrong, and perform the deep debugging it often can't handle itself.
Whereas the AI assistants built right into the IDE.
Those seem destined to become the standard. Tools like CodeGPT, GitHub Copilot, the JetBrains AI, they offer that deep contextual help, understanding the whole repo, knowing the database schema woven directly into your workflow.
So it's more of an incremental productivity boost rather than full autonomy.
Exactly. It's a reliable assistance that makes you faster and better without the high risks and high costs of letting the AI completely take the wheel, at least for now.
So pulling it all together, the final takeaway, show, listening to this, what does it mean for the role of the developer? Are the robots taking over?
Not replaced. Evolving. Fundamentally evolving. You're shifting from being someone who primarily types lines of code
to being more like an architect, a prompter, a validator.
All of the above. You're becoming a meticulous architect who designs the system, a master prompter who can effectively guide the AI, and maybe most importantly, a vigilant security validator who manages the AI's output rather than creating everything from scratch yourself.
And that vigilance is key. You mentioned cultivating a healthy skepticism.
Absolutely critical. You have to operate under the principle. All AI-generated code is untrusted until proven otherwise. Review it, test it, understand it. Because of that inherent bias towards insecurity we discussed.
Yeah.
That mindset is the difference between leveraging AI successfully and, well, potentially introducing the next big vulnerability like slop squatting into your system.
Okay. So we've seen the incredible power of AI to generate code, but also its inherent weaknesses, its vulnerabilities, and how tough it can be to make it work reliably with messy legacy data. Which leaves us with, I think, a really crucial final thought to chew on.
Laid it on us.
If the big problem holding back AI in enterprises now is bad data in siloed legacy systems, what happens in 5 or 10 years after we've potentially flooded the world with new applications built incredibly rapidly using AI, maybe bypassing proper governance, maybe with security flaws baked in by default? Are we just creating the next generation of incredibly complex, possibly insecure, untrusted legacy systems? Are we automating ourselves into a brand new pile of technical debt built on code nobody fully understands or trusts?
That is a sobering thought. The question of future maintainability and trust in this AI-generated world.
Something for everyone to think about.
Definitely. Well, thank you for joining us for this deep dive. Hopefully this SWOT analysis provides a clearer map for navigating the AI development revolution.
We'll see you next time on the Deep Dive.
Welcome to the debate. In, the last year or so, generative AI has really rocketed past just being a cool tool. It's digging right into the foundations of software development. I mean, it's a huge shift, bringing in a whole new set of ways to work. Autonomous coding, these really smart AI agents, structured approaches like spec-driven development or SDD, and maybe the most disruptive one, vibe coding.
Oh, absolutely. The pressure everywhere in the industry is just immense. You've got platforms pushing for raw speed, accessibility speed above everything else, but At the exact same time, the need for solid enterprise-level rigor, security, governance, that's never been more critical.
Right, so the core question that kind of emerges from all this is pretty clear. Do these super autonomous, super fast methods like vibe coding mean we're basically collapsing the distance between just having an idea and getting it running? Maybe even, replacing human developers for a lot of tasks? Or are the new structured ways, like spec-driven development and these AI coding IDEs with a human involved, are they actually showing us that developer know-how and oversight are still fundamentally irreplaceable?
Well, I firmly believe that for software that needs to be production-ready, secure, maintainable, rigor and governance demand these structured, human-centric ways of working. The developer's job is changing, no doubt, but it's actually amplifying their role as the ultimate architect and, crucially, the validator.
And I'm going to argue that the future is really leaning towards maximizing that speed, that automation. The friction's just being stripped away, pushing beyond needing a developer involved at every single step towards a world where maybe the main barrier is just the user's imagination. Okay, so let's kick off with autonomy. We've already seen AI move from just offering suggestions to actually taking autonomous action. It's collapsing development timelines, it's making coding more accessible, democratizing it really. Think about how it's evolved. DeepMind's AlphaCode, that showed it was possible for AI to solve tricky coding competition problems. But now, we're seeing commercial use, tools like Google's Jules. That's an autonomous coding assistant working asynchronously on its own on real big code bases. So the AI isn't just helping anymore, it's operating independently on actual production code. It's becoming the go-to for banging out prototypes quickly. It's more than just chatting with an AI. It's about making it super accessible, letting even non-experts spin up working software fast just by, iteratively vibing with the system. And this really blurs the lines between a rough idea and something functional. A prime example here is Replit Agent 3. It now has, get this, over 200 minutes of unsupervised runtime. It handles its own testing, fixes its own problems. That suggests the agent can genuinely get past the MVP, the minimum viable product stage, all by itself. We're even seeing platforms like Windsurf, where you can basically build a whole functional app from just one conversational prompt. That kind of speed just fundamentally changes how much human input is needed.
That speed is, well, it's definitely eye-catching, I'll give you that. But I have to push back on this idea that the autonomy just translates smoothly into production-ready software. For real-world apps, the kind that need to scale and be reliable, speed has to come second to rigor. You need structured frameworks because AI has inherent limits, especially around security and system stability. And this is exactly where spec-driven development, or SDD, comes in as the necessary counterpoint to just free-form vibe coding. SDD, which we're seeing in tools like Kiro and GitHub Spec Kit, insists that the specification, the document detailing requirements, design, how you know it's done, that is the central guiding thing. The spec guides the AI through distinct phases: specify, plan, tasks, implement. It basically puts guardrails on the AI's speed using traditional planning discipline. And look, developers are also choosing AI coding IDs, things like CodeGPT or the JetBrains AI assistant. These tools bring sophisticated AI help right into the editor they already use. Keeps the developer in control. And that oversight, it's absolutely essential because AI-generated code is often trained on just billions of lines of insecure code samples. The bias is naturally towards making it work, not necessarily making it secure. We're talking common flaws like SQL injection, that's CWE 89, but also these newer risks like hallucinated dependencies or this thing called slop squatting.
Wait, hold on a second. Before we move past that, slop squatting. Can you break that down a bit more? It sounds like a pretty serious, maybe specific, new kind of threat.
Yeah, absolutely. So a hallucinated dependency happens when the language model, trying to generate code that works, it makes up or misspells a package name in the code's dependency list. Then some bad actor sees this, squats on that incorrect package name, that's the slop squatting part, and uploads their own malicious code there. So When the unsuspecting user runs the AI's code, boom, they pull in the malicious package without realizing it. The risk here is, well, you can't just blindly trust AI output. That trust has to be earned, built up through careful verification, step by step, especially when you've got critical risks like that potentially sneaking in silently. Which brings us right to our first big debate point: security and accountability. I'd argue security is the single biggest roadblock to scaling pure autonomy. Vibe coding, just by how it works, iterate fast, figure it out as you go, no formal requirements, it's almost insecure by default. We see these full-stack app generators like Lovable or bluntspace.ai. They promise incredible speed, right? But they put really high-stakes tasks in the hands of users who might be complete novices. Take something like Supabase row-level security, RLS. That's a complex, absolutely critical way to control data access. A novice just prompting for an app could easily mess up the RLS configuration completely, leading to a massive data breach, and they might not even know until it's way too late. The human developer has to remain accountable for the quality and especially the security of that AI code through proper structured approval steps.
Okay, I definitely see the vulnerability there. When novices get powerful tools without supervision, but I'm not totally convinced that means autonomy itself is fundamentally broken. These security worries, they're being tackled by specialized agent architectures, We're not just relying on a general-purpose LLM to suddenly be a security guru. For example, Zencoder uses these proprietary techniques like repo grokking. That means the agent builds a really deep understanding of the whole codebase's architecture, custom logic, internal security stuff before it starts making changes. And even more radically, autonomous agents like Claude Code are actually being used as dedicated code review agents. I mean, the engineers building this tech are using it to review their own code changes. That basically removes the bottleneck of waiting for manual code reviews, giving huge speed boosts without, they argue, sacrificing quality. The developer's role changes, right? Instead of checking every single line the AI spits out, governance focuses on checking the prompt and the plan. You're validating the intent and the high-level approach.
Dedicated security agents are definitely a powerful layer, I agree. But they don't replace the ultimate safety net, the skilled human programmer. Vibe coding, precisely because it prioritizes speed and rapid generation, forces developers to shift their skills. Now they have to rapidly evaluate and debug code they didn't even write. That's a huge cognitive load. And when the AI inevitably hits a wall, fails to fix some subtle architectural bug, what happens? Developers often just ditch the prompt and fix cycle and switch straight to manual debugging, using the good old browser development tools or console logs to find the error the AI couldn't pinpoint. That deep technical expertise is still the final insurance policy. If the AI goes off the rails, you need someone with deep systems knowledge to break out of that frustrating error loop and fix the root cause properly.
I follow the logic there about needing expertise for the really tricky diagnostics. But let's weigh the trade-off. The sheer velocity you get in those early stages often drastically outweighs the risk of hitting a debugging wall later on. And that brings us to the second point, this tension between rigorous planning versus just discovering things as you go. Vibe coding is brilliant at what I'd call progressive discovery. Its conversational style lets a user start with a fuzzy idea and then expand and refine it based on seeing quick, runnable outputs from the AI. When something like Replit Agent 3 can generate working code really early in the process, the speed of getting something runnable is just a massive competitive edge. It's agile in the true sense, right? You avoid all the upfront overhead of overstructuring an idea that might get tossed out next week anyway.
I guess I see it differently. That iterative nature, if it's not constrained somehow, that's exactly where huge technical debt starts piling up. And that's precisely why spec-driven development forces rigor up front. SDD systems like Kiro, they enforce structure by making the specification itself executable. And crucially, Kiro demands you create a constitution, basically a set of hard rules, principles, constraints, dependencies for the project. The AI literally cannot violate these rules. This structures the whole process by forcing you to define the what and the why, the feature spec, before you even think about the how, which is the plan and the tasks. Relying on just vague conversational prompts, that often leads developers right into those frustrating error loops because the fundamental constraints, the Constitution, were never clearly defined at the start.
That sounds a little bit like we're going back to old school waterfall planning, the kind of bureaucracy AI was supposed to free us from. Why would I spend a whole day writing super detailed docs and unit tests for a prototype that might be completely binned by the afternoon? STD seems like it risks serious over-engineering for MVPs and quick proof of concepts.
Well, I wouldn't call it waterfall. Maybe constrained agility? And look, we are seeing lighter versions emerging that address exactly that concern. GitHub Spec Kit, for instance, lets the specs just be simple markdown files. They're easy to change. They're not these rigid, unchangeable things carved in stone. But the key difference is alignment. That little bit of necessary friction up front, defining things clearly, it ensures the AI and the developer are pulling in the exact same direction. It reduces the long-term risk of the architecture just decaying into a mess.
Okay, this whole discussion about structure and rules leads us pretty neatly into the most complex area right now, agentic workflows. When we talk about autonomy, we really need to be clear about the difference between simple, predefined workflows and true dynamic agents.
Yes, I agree. That distinction is absolutely critical if we want to understand where humans still fit in the picture. Workflows, the kind you build with Zapier, Make.com, Power Automate, they link together LLMs and tools using predefined paths, usually rule-based. Something triggers it, a webhook comes in, a database row changes, and it follows the script. They're reliable for repetitive stuff, sure, but they're fundamentally static. True agents, on the other hand, they dynamically figure out their own processes, how to use tools, actively pursuing goals. They trade off a bit more latency, maybe higher cost, for much better, more adaptive performance on complex tasks. We really need to resist adding agentic complexity just because we can. If a simple workflow does the job, use the workflow.
But the real cutting edge, the true innovation, is in orchestrating multiple agents together, where human oversight starts to fade out entirely for whole complex processes. Think about platforms like Relevance AI or Google Agent Space. They're connecting specialized agents using open protocols like agent-to-agent or A-to-A.
Okay, A to A. Tell us a bit more about that. What does that actually mean for developers, practically speaking?
Well, A2A lets agents discover what other agents can do automatically, negotiate how they'll interact, and keep track of context across different systems. It's fundamental for real autonomy. Imagine this, a complex sales process handled end-to-end by agents. One agent pulls data from the CRM, another analyzes buying patterns, a third generates a personalized invoice in the accounting system, and a fourth logs the whole thing, all connected, all executed, without a human clicking anything. That level of self-directed, integrated work, it's just impossible with traditional software or simple workflows. It shows the potential to actually replace human steps across defined business processes.
But that level of operational autonomy, it absolutely demands an equally robust level of governance. And this is precisely where human expertise comes back into the loop, maybe in a new role. We need transparency tools, ways to understand why the agents made the choices they did. We need mandatory fail-safes, ways to step in or shut down agents if they start drifting away from their defined constitution, or if they get targeted by, say, adversarial attacks. In really critical regulated areas like finance, the human expert basically becomes a governance specialist. Their job is validating what these autonomous agents are doing, making sure it's ethical, making sure it meets compliance rules. The sheer complexity of these interconnected, self-directing systems makes human accountability absolutely non-negotiable.
Look, ultimately, these new trends are pointing towards the developer evolving, yeah? Becoming more like a high-level conductor, a concept manager, maximizing their productivity by basically outsourcing big chunks of the actual coding to these capable agents. The biggest win here is the huge drop in friction and just the raw speed you get with tools like Replit Agent 3 and Windsurf. It's fundamentally changing the path from idea to running code. The era of the person coding line by line, the functional programmer, it feels like it's undeniably fading, being replaced by the prompt engineer and the agent orchestrator.
And while that speed is definitely appealing, For high-stakes development, you have to move away from just the conceptual vibe and towards verifiable, structured methods like SDD, the kind embodied by systems like Curo. The human role isn't vanishing, it's being amplified and shifted. You're moving from being the code author to being the meticulous architect, the validator, the person who maintains those critical security and governance frameworks. The developer is the one ensuring the constitution is respected, that compliance is met, preventing those massive liability risks that come with completely unchecked autonomy.
Yeah, the material we've looked at definitely shows that both these directions, maximum speed through autonomy and maximum rigor through structure, are moving forward incredibly fast and really changing the whole game.
Leaving every single organization with a tough choice about where they place their operational trust. Do you bet on the pure velocity of these fully autonomous systems, or do you stick with the verifiable rigor of human-led, spec-driven development?
There's clearly a lot more to unpack here.
Welcome back. So this week, we looked at material covering the new wave in software development, things like autonomous coding, AI agents, spec-driven development, vibe coding, basically AI getting really embedded in how we build things.
Right. A lot about speed, accessibility.
Exactly. The pieces really highlighted the sheer velocity you get with tools like Windsurf or Cursor, or just Copilot in VS Code, JetBrains AI assistant.
Yeah, getting devs into that flow state.
But it begs the question, doesn't it? Speed's great, but what about the trade-offs, particularly around security?
That's the core tension, I think. And maybe we haven't fully squared how that speed, well, it directly bumps up the exposure if security isn't baked in from the start. The material does a pretty good job detailing the risks we know about with AI code, but I think to really land the point, it needs to more strongly frame the developer's role shift. It's less about banging out lines of code, and much more about being like a meticulous architect, a really good prompter, and crucially, a vigilant security validator. That's key to tackling the risks from tools that, frankly, encourage a bit of material disengagement.
Material disengagement? You mean like you trust it because it seems to work functionally, even if there are hidden traps? The notes mention things like SQL injection, the old CWE 89, just popping up again but faster,
leading to slop squatting.
Yeah, and the problem is, the sheer productivity you get from vibe coding, especially with those rapid full-stack tools like Lovable or Bolt, it makes you want to trust it. The AI models, they're optimizing for does it run, not necessarily is it secure. That's how you rack up serious security debt without even realizing it.
Okay, so we can't just say, don't use these tools. That's not realistic.
No, not at all. They're too powerful. The real solution, I think, is to formalize the human expertise within the workflow itself. The discussion really needs to hammer home, treat all AI-generated code as untrusted by default.
Untrusted until verified.
Precisely. You need that mandatory human-in-the-loop check for anything high-risk before it gets accepted.
So the human value shifts to synthesis, validation, security oversight, not just typing. But how do you make that validation systematic? Doesn't adding checks kind of kill the whole speed promise of vibe coding?
Not if you embed the checks smartly. Make them part of the automated process. So, okay, for actionable steps, we could suggest maybe 3 things. First, really push for integrating automated supply chain security checks right into the CI/CD pipeline. That's got to be table stakes, especially when these tools pull in tons of dependencies.
Non-negotiable for those full-stack generators.
Absolutely. Second, suggest actually implementing PULP, the principle of least privilege, but for the AI agents themselves.
Oh, interesting.
Yeah, like requiring explicit human approval before an agent can touch high-risk things, maybe modifying environment secrets or core infrastructure settings.
That's a really important guardrail, applying infra-security thinking to the AI layer itself.
Exactly. And third, make SAST, static application security testing, mandatory. It needs to run and pass flagging insecure patterns like, say, unsafe string concatenation for SQL queries, before any AI-generated PR even gets looked at for merging. Security review becomes part of the definition of done.
Okay, that really reframes the risk, and it puts the developer's expertise squarely on that architectural oversight level. which actually leads nicely into the next point about, well, development methodology itself. Yeah, the material did a good job drawing that line between, the fast conversational feel of vibe coding, great for knocking out prototypes, and the more structured, rigorous approach of spec-driven development, SDD. The idea with SDD, as I got it, is the spec isn't just a doc, it is the executable artifact, right? Enforced by tools like GitHub Spec Kit or Curmo.
Right, it draws the distinction, but we need to connect the dots more clearly, I think. While the material establishes vibe coding and SDD as two distinct paradigms, one driven by speed, the other by rigor, a clearer strategic framework is needed to guide developers on when, and importantly, how, to transition from that loose vibe coding feel to the necessary rigor of SDD.
Yeah, I can see that. Because we've all been there, right? That quick prototype code somehow ends up sticking around in production way too long.
Mm-hmm.
And the analysis right now, it maybe makes the choice feel a bit too much about just picking a tool like Vibe for Vibe, Kiro for Spec. It needs more of a product lifecycle strategy behind it. How do you formalize that pivot point?
Well, I think we have to clearly define the specification itself as that critical strategic gate. It's the point where a rapid sketch proves viable and needs to become stable, production-ready code. So position vibe coding explicitly as like the ideation phase, the rapid sketching, the viability testing.
Okay.
And then SDD is the essential production-ready phase. That's where you bring in the guardrails, the maintainability, the scale.
So the spec becomes the executable structure. It ensures that whatever creative stuff the AI churned out during vibe coding actually gets wrangled into something scalable and maintainable. How do you enforce that transition, though?
Okay, concretely, think about organizational enforcement. Suggest that those initial high-level vibe coding prompts, the just sketch out this idea type stuff, must give way to that formal, multi-phase SDD structure. First, specify the what and why, then plan the how and the constraints, then break it down into tasks, and only then do you implement. And a really tangible example here is using something like the GitHub Spec Kit commands, like specify and knit. That shows how an organization can literally embed non-negotiable standards, call it a project constitution, right at the start.
Ah, okay.
Like mandating, say, we will use Next.js for the front end before the AI even generates a line of code. It anchors the whole thing to best practices from the get-go. The AI has to work within those bounds.
That makes the spec the central governor, yeah? It feels like the spec review, maybe an acceptance checklist based on it, that has to be the hard checkpoint before anything vibe-coded gets promoted into that formal implementation phase. The spec decides if the AI's output is actually ready for prime time.
Exactly. It formalizes the handover.
Okay, so if specs provide that architectural structure for the human-AI interaction, what about the communication between the AIs, between the agents themselves? I thought the detail on specialized agents was great. Harvey AI for legal, Lindy AI, Claude Code, and how they plug into workflow tools like NN or Make.com.
Yeah, that part laid a good foundation. But to really tackle the big enterprise challenges, and frankly, to reflect where things are heading now, it needs to push beyond just linear, rule-based automation flows. The material sets a strong foundation for how AI agents integrate systems, but to address enterprise-level challenges, it should elevate the discussion to the strategic importance of the emerging agent-to-agent, 8-to-8 protocol, and these unified orchestration layers.
Right, because a lot of the current examples, like automating email handling or updating spreadsheets via NNN, they feel quite rigid, don't they? Trigger, action, output. It's a lot like traditional software automation, just maybe with an AI step in the middle.
It is. It kind of misses the magic, the dynamic reasoning part. That linear setup overlooks the real power, which is agents dynamically figuring out their own processes, collaborating across different platforms based on that core agent loop. Understand, think, act. The strategic angle really needs to pivot towards interoperability and dynamic decision-making.
Okay, so you're saying agent platforms are moving towards letting agents, discover and negotiate capabilities with other specialized agents, even if they're built totally differently? What does this A-to-A protocol actually do?
Think of it as enabling that negotiation, breaking down silos between specialist agents. So contrast that rigid, rule-based flow with, say, an AI agent using A2A, because a sales agent suddenly realizes it needs data from a totally separate compliance agent built on some proprietary internal system. A2A is like the handshake protocol that lets them talk and potentially exchange information or tasks dynamically.
Can you give like a concrete example of that dynamic reasoning where the agent isn't just following a preset flowchart?
Sure. Okay, instead of a fixed instruction path, like every Monday, check calendar for X, then do Y. Imagine a more complex goal, like maintain positive cash flow. The AI agent, based on current conditions, might dynamically decide the best immediate action is to access QuickBooks via its API, pull a list of overdue invoices, and then maybe draft reminder emails.
So it's not just a fixed trigger. It's assessing the situation and choosing the tool or path.
Exactly. It executes based on real-time context and its understanding of the goal. And yeah, platforms like Google's Vertex AI Agent Builder, Microsoft Copilot Studio, even open systems like NN, they provide the canvas, the orchestration layer to chain these actions together. But the material needs to really emphasize that it's the agent's dynamic reasoning that's the game changer, setting it apart from simple static workflows. It's the difference between just a trigger and an actual strategic decision maker.
Got it. That definitely puts agentic workflow in a much richer context than just focusing on the automation tools alone. Okay, so let's wrap this up. We've pinpointed, 3 core areas where this already strong material could be sharpened strategically, really focusing on boosting the impact for readers digging into these new dev trends.
Yeah, I think the overarching goal is adding that layer of structural rigor around these incredibly fast tools. For the listener, the most actionable things are probably first, defining that formal security validation step, embedding things like SAST, maybe POPLI requirements, before signing off on any AI-generated code.
Right. Treat it as untrusted.
Typing to solid production code.
And the third piece was recognizing that AI agents need to evolve past simple linear automation towards genuine A-to-A interoperability and that dynamic reasoning capability.
Moving beyond static workflows.
Great. So, the challenge now is to take these strategic refinements on board. We definitely invite you to polish the material with these thoughts in mind, and feel free to submit the improved version back to the critique. We'd be keen to see it.